Hello and welcome to this video on current, resistance and potential difference. This is for GCSE Physics and Combined Physics, and don't forget to like and subscribe. The charge on one electron is too small to be particularly useful when thinking about circuits, so a large number of electrons grouped together is used instead. Approximately 6 million electrons together make a total charge of 1 coulomb. Each bucket represents 1 coulomb of electrons. The amount of charge that passes a point every second can be measured using an ammeter. As the charge has to pass through the ammeter to be measured, the ammeter has to be in series with the circuit. The faster the charge moves around the circuit, the more charge moves through the ammeter every second. This gives a bigger reading. This measurement is called the current. It's the amount of charge that passes a point every second, and its unit is the amp, capital A. Charge, current and time are related with this equation. Charge equals current times the time, or Q equals I times T. The units: charge Q is in coulombs, capital C, current I is in amps, capital A, and time T is in seconds, little s. Charge will only flow in one direction around a circuit if there is a power supply to cause the charge to flow. The power supply provides a potential difference to the circuit. The greater the potential difference, the faster the charge moves around the circuit. Potential difference tells us the amount of energy in each coulomb of charge. This energy is then transferred to other energy stores as the charge overcomes the resistance in the circuit. In this circuit, the only component is the bulb. This is the only thing providing resistance in the circuit. The wires and the ammeter have very little resistance, so small that it can be ignored. A 12-volt power supply transfers 12 joules of energy to each coulomb of charge. Each coulomb of charge, represented by the buckets, can do 12 joules of work against the resistance in the circuit. On this side of the bulb, the buckets, 1 coulomb of charge, have 12 joules each. On this side of the bulb, the buckets, 1 coulomb of charge, have 0 joules. All of the energy has been used to overcome the resistance. The work done against the resistance is why the bulb lights up. The voltmeter detects the difference in the two potential differences and will report a value of 12 volts. Potential difference is the difference in the ability to do work between 2 points in a circuit. Potential difference: the difference in the ability of a coulomb of charge to do work between 2 points. It has the symbol of capital V and the units of volts, symbols also capital V. Voltage is related to charge with the following equation: E equals Q times V, or energy equals the charge multiplied by potential difference. The units: energy E is in joules, capital J, charge Q is in coulombs, capital C, and potential difference V is in volts, capital V. Potential difference is the amount of energy per coulomb of charge, or to put it another way, 1 joule per coulomb equals 1 volt. 10 joules of energy are transferred to 2 coulombs of charge. What will the potential difference be? So we start with our equation, E equals Q times V, then substitute in our numbers from the information in the question, so that's 10 equals 2 times V. Then we need to make V the subject, so we need to divide through by 2, and that gives us 10 divided by 2, which equals V, and that gives us a final answer of 5 volts. Resistance. This works to slow the flow of charge. The greater the resistance, the smaller the current. Resistance has the symbol capital R and the unit is the ohm, and the symbol is the Greek letter capital omega. As the electrons, the charge, move through the circuit, they collide with the lattice ions. The greater the frequency of the collisions, the greater the resistance and the lower the current. Resistance is related to potential difference and current with the following equation: V equals I times R, or potential difference equals current times the resistance. The units: potential difference V are in volts, capital V, current I is in amps, capital A, and the resistance R is in ohms, capital omega. From this equation, you can see that the larger the potential difference, the larger the current for a fixed value of resistance, and the smaller the resistance, the larger the current for a fixed value of potential difference. In this circuit, we can change the potential difference and see what happens to the current. So we'll start with a potential difference from the cells of 1.5 volts. And we have a fixed resistance of 6 ohms. If we substitute that into our equation, we get 1.5 equals I multiplied by 6. Rearranged to get I on its own is 1.5 divided by 6, and that gives us 0.25 amps. Now if we keep the resistance the same at 6 ohms, but change the potential difference coming from the cells and increase it to 4.5 volts, we now have 4.5 equals I times 6. Rearrange that to get I, so it's 4.5 divided by 6, and that gives us a current of 0.75 amps. So as you can see, if you increase the potential difference, you increase the current. In this next circuit, we're going to keep the potential difference from the cell the same, but we're going to alter the resistance. First of all, we're going to start with a resistance of 6. So as before, we have 1.5 volts equals I times by our resistance, which is 6 ohms. If we rearrange this to get the current, we get 1.5 divided by 6, which gives us a current of 0.25 amps. Now, if we decrease our resistance to 3 ohms, we substitute in our numbers again. 1.5 volts equals I multiplied by 3. Rearrange to get I, so that gives us 1.5 divided by 3, and that gives us an answer of 0.5 amps. So you can see if you decrease the resistance, then you're going to increase the current. And that's all for this video. Thank you so much for listening.